Okay, so we are going to work problems 5 through 9. Let's go ahead and start with problem number 5 on page 18. So air at 30,000 feet at a temperature of minus 35 degrees C. Air is a mixture that is 78% nitrogen, 21% oxygen, and 1% argon. If 0.594 moles of air are captured in a 45-liter container from a plane flying at 30,000 feet, 1. Calculate the total pressure, and B, calculate the partial pressures. Okay. So if we're going to calculate the total pressure in the very beginning, the way we're going to define that is with PivNerd. So I know that the total pressure, I'm going to call this 5A, the total pressure times the volume is equal to the moles of gas times R times the temperature. Now in this case, our temperature is 273.15 minus 35, which is 238.15 Kelvin. Okay, so I basically have the volume of the whole system, the moles of the whole system, and the temperature of the total system at 30,000 feet. So I'm just going to plug it all in, right? This is going to be 45.0 liters. This is going to be 0.594 moles of the total gas. I'm going to use 08206 for R and 238.15 K for that. I'm going to divide both sides by 45, right? And that means P total is equal to 0.258 atmospheres. That's my total. All right, now for B, what we want to do is calculate the partial pressures of each gas. Now, if I wanted to calculate the partial pressure of N2, that would be the mole fraction, the quantity, the mole fraction of N2 to the moles total times P total. Well, I have that. What I need is sigma. Now, when I say that the gas N2 is 78% of the mixture, what I'm basically saying, it's 0.78 out of 1. Because times the 100 gives me my percent. That is my mole fraction. So now I've got everything I need to calculate the partial pressure of N2. It's going to be 0.78 times 0.58 atmospheres, and that gives me 0.201 atmospheres. I do the same for oxygen, except this time it's 0.21 times 0.258 atmospheres, and that gives me 0.0540 atmospheres. Okay, and then last but not least, I get 0.01 times 0.58 atmospheres, and that gives me 0.00258 atmospheres. So you can see that what I did is I made use of that percentage, pulled the mole fraction out of the percentage, and that allowed me to calculate the partial pressure. Okay, the next problem we're going to work is number 6. Now, number 6, they give you the chemical equation of potassium chlorite going to potassium chloride and oxygen. And it says, how many grams of potassium chlorate were reacted if 5.3 liters of oxygen were produced at 117 degrees C and 0.995 atmospheres? Now, automatically we know we cannot use 1 mole is equal to 22.4 liters because we are not at STP. We have these other conditions. So what we're going to have to do is we're going to have to break the problem up. We can, so here, let's diagram it out. So basically what's happening is that I have 2 moles of potassium chlorate, and it's going to go to potassium chloride, and 3 moles of oxygen. Again, we can't use regular stoic. Basically, we're going to go from here to here. This is our given, and this is our wanted. Now, what do we have as our given? Well, our given is all in terms of Pivnert. I have 5.3 liters. I have 117 degrees C, or 273 plus 117 is going to be equal to 390 degrees K. What else do I have in this problem? I also have 0.995 atmospheres. So given all this, these are my given. I can then find N. Of course, if we want to find mass, our want is in grams. I need to get either grams or mass, so I'm just going to go to moles, and then I can walk from moles to here. So this is going to be a Pivnert then stoic problem. So let's plug everything in. N is equal to P times V divided by R times T. I've just rearranged the equation, and that turns out to be P, which is 0.995 atmospheres, times V, which is 5.30 liters, divided by R, 0.08206, times 390 K, and that turns out to be 0.165 moles. All right, there's my moles. So actually now what I'm going to do is I'm going to say I have 0.165 mole O2. How many grams of potassium chlorate would that be? So let's do that next. So I've got 0.165 moles of O2. I drop my mole of O2 and go to mole potassium chlorate. This is a 3:2 ratio based on the stoic or the coefficients, right? But I need to go to grams, so I'm going to drop mole and go to grams. And 1 mole of this is 122.6 grams. So that turns out to be 13.5 grams potassium chlorate. So again, that was a Pivnert then stoic problem. All right, the next problem we're going to look at is number 7. What is the density of NO2 at 25 degrees C and 2.56 atmospheres? Okay, now the first thing I want to do for this one is I'm going to write down what is the equation for density. Density is mass over volume. Okay, now I've got pressure and temperature information. I've got a pressure of 2.56 atmospheres, and I've got a temperature of 273.15 plus 25 degrees C, which is going to be 298.15 K. Now, let's look at our Pivnert equation. P times V is equal to N times R times T. Now, how can I get this equation to express mass? Well, I can change. We know that moles is equal to mass divided by the molar mass of my compound. So I'm going to plug that in. P times V is equal to little m divided by big M times RT. All right, I want to try to get, really what I'm shooting for is trying to get M over V by itself, because that's density. So the rest is a bunch of algebra. The first thing I'm going to do is I'm going to take M, I'm going to try to get M over here, so I'm going to multiply both sides by M. That gives me M times P times V is equal to little m times R times T. Now I want to get V over here. So I'm going to divide both sides by V. And that gives me M times P is equal to little m divided by V times RT. All right, that's good. That's my density. But now I just need to get rid of RT. So I'm going to divide both sides by RT. And I end up getting M over V is equal to the molar mass times the pressure divided by RT. Okay? So, let's put that in. Right? The molar mass of NO2 is 46 grams. That's the molar mass of NO2. So I'm going to put that here. Molar mass of NO2 is 46.0 grams times the pressure, which is 2.56 atmospheres, divided by 0.0821 and divided by 298. My density is 4.81 grams per liter. So make sure that you note that the volume, we know that mass is in grams, but in this case, because of it's in this ideal gas law, volume is in liters.